Hello everyone, and welcome to our YouTube video on mastering unit testing in Python. Whether you're a seasoned developer or just getting started with Python programming, understanding unit tests is crucial for building reliable and maintainable software applications. So if you are ready, let's get started. Unit tests in Python, like in any other programming language, are a fundamental aspect of software development aimed at ensuring the correctness and reliability of individual units or components of code. They form the backbone of a comprehensive testing strategy and are essential for maintaining code quality, enabling easier debugging, and promoting robust software design. So, let's understand, what are unit tests? Unit testing is a software testing technique where individual units or components of a software application are tested in isolation to verify that each unit performs as expected. A unit typically refers to the smallest testable part of an application, such as functions, methods, or classes. By isolating units from the rest of the system, unit tests help identify defects early in the development process, making it easier and more cost-effective to fix them. Importance of unit testing. 1. Early detection of defects. Unit tests allow developers to identify and fix bugs at an early stage of development, preventing them from propagating to other parts of the system and becoming more challenging to resolve. 2. Code quality assurance. Writing unit tests encourages developers to write modular, well-structured, and maintainable code. It also promotes adherence to coding standards and best practices. 3. Facilitates refactoring. Unit tests provide a safety net when refactoring code. Developers can make changes to the codebase confidently, knowing that unit tests will catch any regressions introduced during the process. 4. Documentation. Unit tests serve as executable documentation, illustrating how individual components of the system are expected to behave. They help developers understand the intended functionality of each unit and serve as living examples of usage. 5. Regression testing. Unit tests can be automated and executed frequently, allowing developers to quickly identify regressions caused by new code changes or updates to dependencies. 6. Improved collaboration. Unit tests serve as a form of communication among team members, helping them understand the functionality of each unit and the requirements it fulfills. Anatomy of a unit test. A typical unit test consists of three main phases: setup, execution, and assertion. 1. Setup. In this phase, the test environment is prepared, including initializing any necessary objects, setting up mock data, or configuring the system under test. 2. Execution. The unit or component being tested is invoked with specific inputs or parameters. 3. Assertion. The output or behavior of the unit under test is compared against expected outcomes using assertion statements. If the actual output matches the expected output, the test passes, otherwise, it fails. Writing unit tests in Python. Python provides a built-in module called unittest for writing and executing unit tests. The unittest module follows the xunit style of testing and provides a framework for organizing test cases, fixtures, and assertions. Here's a simple example demonstrating how to write unit tests in Python using the unittest module. In this example, we define a function add that adds two numbers. We create a test case class testadd function that inherits from unittest.testCase. We define three test methods: test_add_positive_numbers, test_add_negative_numbers, and test_add_mixed_numbers, each containing assertion statements to verify the behavior of the add function under different scenarios. We execute the tests using unittest.main. Best practices for writing unit tests. 1. Test one thing at a time. Each unit test should focus on testing a single behavior or aspect of the unit under test. This makes tests easier to understand and diagnose when failures occur. 2. Use descriptive test names. Choose descriptive names for test methods that clearly indicate what aspect of the unit is being tested and what conditions are being evaluated. 3. Isolate tests. Ensure that each test is independent of others and does not rely on external state or the outcomes of other tests. This helps identify the root cause of failures more easily. 4. Use test fixtures. Use setup and teardown methods to create a consistent test environment and clean up any resources or state after each test is executed. 5. Mock external dependencies. When testing units with external dependencies, e.g., databases, APIs, use mocking frameworks to simulate these dependencies and control their behavior during testing. 6. Run tests automatically. Automate the execution of unit tests as part of the continuous integration (CI) process to ensure that new code changes do not introduce regressions. 7. Test edge cases. Ensure that unit tests cover a variety of input values, including edge cases and boundary conditions, to validate the robustness and correctness of the unit under test. Conclusion. Unit testing is a critical practice in software development that promotes code reliability, maintainability, and quality. By writing automated tests for individual units or components, developers can detect defects early, improve code readability, and build confidence in the correctness of their software. Python's unittest module provides a powerful framework for writing and executing unit tests, enabling developers to create robust and dependable software applications. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.